Hello Math130 students, we are going to continue on page 16, section 4.5, the greatest common factor and factoring by grouping. So here we want to think about the GCF, or the greatest common factor. So for example, let's look at 36 and 54. So what two numbers multiply to give you 36? Well, 1 times 36, 2 times 18, 3 times 12, and so on. Same thing with the factors of 54. What two numbers multiply to give you 54? 1 times 54, 2 times 54, 3 times 18. So we keep thinking about these factors, right? Two numbers that multiply together to give you 54. So if we can think about it that way, well, we can see that 18 is going to be the biggest common factor that these two numbers have. So that would be your GCF, okay? It is the number that is shared between 36 and 54. So 18 times 2 is 36, and 3 times 18 is equal to 54. So let's think about the GCF, or the greatest common factor, from polynomial expressions. So from the first example, we have negative 42 and 30. So the first thing you want to look at is going to be the numbers 42 and 30. So what are the multiples of 42, let's say? Well, we have 1 times 42, 2 times 21, 3 times, let's see, 42 divided by 3 is 14. 5 does not go into it. And 6 times 7 is all part of 42. Now, let's look at our multiples, or our factors, of 30. We have 1 times 30, 2 times 15, 3 times 10. 4 does not go into it, but we also have a 5 times 6. So we want to think about the biggest number that goes into 42 and 30. Well, it looks like the biggest number here would be a 6. So 6 is going to be the number that I'm going to pull out. And because the leading coefficient is negative, I'm going to say it's a negative x. Now, the next thing we want to think about is our x values. What is the smallest exponent on the x? Well, I have an x to a 3, and I also have an x to the 1. So the x with the smallest exponent on it will be part of the GCF, so that would be 6x to the 1. So that is going to be my GCF. So now you want to think about, you're going to be dividing. So you're going to divide negative 42 divided by a negative 6, because that's what you're pulling out, and that would be a positive 7. If you have an x to a 3 and you divide it on x to the 1, you would have an x squared. Now, for the next term, you can think about it as a negative 30 divided by negative 6, and that's going to give you a positive 5. And for your x's, well, x divided by x gives you, x to the 0, which is just 1, so we're just left with that 5. I'm just going to write that 5 just a little bit nicer. There we go. So that is going to be my final answer, negative 6x, and then 7x squared plus 5 inside a parentheses or a brackets. And that's how I factored out with the greatest common factor. So for number 2, let's look at all our coefficients. We have 12, 42, and 42. So the biggest factor that goes into all three numbers, well, 12 does not go into 42, but I do believe that 6 goes into 42. So then 6 is going to be our greatest common factor. So 6 is the number that they all have in common. Now let's look at our variables. We have x to the 3, an x, and an x. So it looks like the part of the GCF will be an x because it's the one with the smallest exponent. And here, let's look at the y's. I have a y here and I have a y here, but there isn't any y there. Remember, a common factor has to be common in all three terms. So here, you do not have a y as common factor because it does not exist in all three. So now I'm going to divide a 6x from each term. So if I have a 12 divided by 6, I get a 2. x3 divided by x, I have an x squared. 42 divided by 6 gives me a 7. The x's cancel and I have a y to the 6. Plus 42 divided by 6 is 7 again. The x's cancel and I have a y. So that is going to be my final answer with the greatest common factor. Now with number 3, I'm going to look at my numbers again. So I'm looking at negative 32, I'm looking at a positive 14. So 32 is an even number and 14 is an even number. Let's see if I can break this down. Well, I know that 14 can be divided by 2 and by 7. 7 does not divide 32. That's not possible. But 2 does. So here my GCF is going to be 2. And since that leading coefficient is negative, then my GCF is going to be a negative 2. Now let's focus on the m part of this. So if I'm looking at the m, I do have an m in both terms, and the smallest exponent is m to the 1 power. Now I'm going to be looking at my n powers. If I'm looking at my n powers, they both have an n in both terms, and the smallest exponent is n squared, so that's going to be part of my GCF. So now that GCF is what I'm going to be dividing from each term. So negative 32 divided by 2 is going to give me a 16. I'm going to have an m3, and the n's cancel out. Plus, now I have a 14 divided by a negative 2, which would give me a negative 7. So I'm going to change that to a negative, or subtraction. Subtract 7. The m cancels, and it looks like you need one more m for your final answer. Okay. Now for number 4, I have 3 different terms. So again, first I'm going to concentrate on the coefficients. So I'm looking at 42, 9, and 18. So I know, let's look at the smallest number here. I'm looking at 9. Well, that can only be 3 times 3. And 18 can be 9 times 2. And 3 times 3 is in that. But if I'm looking at 42, I know that's my 6 times my 7. So 7 isn't going to be a part of it. But I know that's 2 times 3. So it looks like the biggest common factor here is going to be my 3. That's common in everything. So I'm going to make sure that my GCF then is going to include a positive 3. Now I'm going to look at my p-value. Here's p4, p3, and p squared. So the smallest p that they all have in common would be a p squared. Now I'm going to look at my q's. Here's a q, here's a q, ooh, but that first term does not have a q, so therefore it would not be part of my GCF because it needs to be true in all 3 terms. So now I am certain of my GCF, so now I'm going to divide that out from each term. So I have a 42 divided by 3, which is going to give me a 14. P to the 4 divided by p squared gives me p2. 9 divided by 3 is going to be a positive 3. I need one more p, and I need a q squared. Minus 18 divided by 3 gives me a positive 6. My p's cancel out, and I need a q squared. And that is going to be my final answer. Now, what we're going to do is we're going to factor polynomials by grouping. So here is kind of your step-by-step direction. So the first step, we're going to divide the polynomial into 2 groups, the first half and the second half. Then we're going to find the GCF of the first half and factor the GCF of the second half. Step 3, we should have a common factor. Step 4, factor out that common factor. So we're going to use these steps as we work out the following problems. So look at number 1. So the first thing we want to do is we want to divide the polynomial. So you want to make sure it's right behind the second term and not cutting off that sign. So from the first two, if I look at just this half right here, that's the only thing I'm looking at, I want to find my GCF there. So the GCF there would be x. So I'm left with an x minus a 3. Now I want to ignore that half, and I want to think about this half over here. So that half, it looks like I have a negative 5, since the leading coefficient is negative. So I'll be left with an x, and 15 divided by a negative 5 will give you a negative 3. So now I want to see what would be the common bubble or the common parentheses that they both have. Well, this x minus 3 is true for both of these. So I'm going to have an x minus 3 as your common parentheses. And whatever is left over goes in your second set of parentheses. So that would be your x minus your 5. So that ends up becoming your final answer. Okay, let's try that again for number 2. So again, I'm going to split it in half after the second term, making sure I don't really cut off that sign for that third term. I'm going to focus on these two terms, what they have as a GCF. So it looks like they both have a v in common, so I'm left with a u minus a 3. Now I'm going to ignore that half. Now I'm going to concentrate on that second half. So it looks like it's a negative 4 that they have in common. So I'm left with a u minus 3. And now I want to look at the common parentheses. So the common parentheses that they both have in common in both terms is that u minus a 3. So whatever is left over is going to go in its own parentheses. So here would be that v minus the 4. So that is how I'm going to get my final answer. And we can do that again for number 3. So I'm going to go ahead and split it. Think about the first two, what they have in common. So it looks like it's a b, so I'm left with an a plus 10. My second half, it looks like it's a negative 1, so I have an a plus 10. So my common parentheses in both terms is an a plus 10. And whatever is left over goes in its own parentheses, so that would be my b minus my 1. So that gives me my final answer. For number 4, same process. So I'm going to go ahead and split it. The first two have an s in common, so I'm left with an r minus a 5. The second half gives me a 5 in common, so I'm left with an r minus a 5. So the parentheses that they both have in common would be that r minus a 5. And now my leftover parentheses is going to be my s plus 5. I'm just going to make this a little bit nicer and make sure that you guys know that this is a 5. Okay, and so that will be my final answer. And that is the end of section 4.5. If you guys have any questions, please feel free to email me or the Math Success Center or our embedded tutor. Thank you.